Well, we talked about confidence intervals for proportions. Now we're going to talk about hypotheses tests for proportions. So when we do a hypotheses test, what we're generally starting with the hypotheses, is some claim that we think to be true. So you always start, just like in science, you start with some hypotheses or claim that you believe is true. The second thing we're going to have to do is we would gather our data. And what we're going to do when we gather data, and a lot of times in this case we're going to have the data provided for us. So when we gather our data, we're going to use that to test our claim. Again, very similar to what you do in a science class if you were doing some kind of an experiment. Then the third thing we need to do is we need to, once we're using our data, we want to decide how unusual is our sample data. And what we're going to do is we're going to make a decision, and our decision will be one of two things. Our decision will either be, the first decision we might make is to retain our hypotheses or hypothesis, or we might reject our hypothesis. What we're looking for is if our sample data is really unusual, if it's very unlikely to occur, well then we're going to reject our original hypothesis, whatever that would have been. But if our data is not that unusual, then what we say, we retain our hypothesis. And we'll talk a little bit more about that. Always remember, and I'm going to have a number 4, we're always going to add context. So you always have to make sure that you give your final interpretation of your test, your final description. Make sure that you add context to that. All right, Mars Candy Company claimed that 24% of plain M&Ms are blue. And our question here is, does evidence support that claim? Now, we looked at this with a confidence interval in class. Now we're going to look at this with what's called a hypothesis test. And when we do a hypothesis test for proportions, we always start with what's called the Null Hypothesis. And the notation we use is an H for hypothesis, H naught, N-A-U-G-H-T, H naught. And for our Null Hypothesis, for H naught, we're going to say what the Mars Candy Company claims. So they claim that P equals 0.24. The proportion of blue M&Ms manufactured, I don't know, do you manufacture M&Ms? Is 0.24. So a lot of times you'll see this, your null hypothesis written in the symbol and then also in words. And that's a good habit to get into, because later when you give your interpretation, you can look back up to the words you used and use those same words. Now, one thing I want to point out is never, ever, ever, never use p hat. Your hypotheses are always about the parameters, never about the statistic. Then what we have to do is we need an alternative hypothesis that we're testing this against. And so we use HA for alternative hypotheses. Now this is going to depend on the question asked. Now this question says, does evidence support that claim? Sometimes you're asked something like, is the proportion less than 0.24, or is it greater than? But here, we're not really given a direction, less than or greater than. So I'm going to say P is not equal to 0.24. And there will be some things that we have to handle it a little differently when this is called a two-sided hypotheses test, and we'll also see some one-sided hypotheses tests, and there is a little bit of difference how we have to interpret some of our results when we do that. I'm not going to write this part out in words. Since I had the other, we could just see what is not 0.24. By the way, this is called our alternative hypothesis. Now, when we do this, we're going to be using, we have to select our model, and we're going to be using a normal model. But in order to use a normal model, certain conditions have to apply. So we're going to have to test those conditions. Now, the good thing is, for the most part, they're the same conditions that we tested for confidence intervals. We have to make sure that it's a random sample. So we have to address this idea of randomness. Now, we didn't really have a random sample, so but I still have to address that. So I believe that it's reasonable that our sample is representative of all M&Ms produced. So you have to be able to address that situation. If it's not a random sample, make sure that you at least address this. Remember, we're not doing random check mark. You have to address the situation. The independence issue since I'm treating it like as if it's a random sample, it's representative of the M&Ms. Each color should be independent of the other. All right, the 10% condition, we could say, now remember for our sample, we had 1,019. So 1,019 is definitely less than 10% of all plain M&Ms, as we talked about in class. Many of us decided we've eaten more than 10,190 plain M&Ms. Now the last one is going to be a little bit different because we're going to assume, remember in our null hypotheses, we said that the true proportion is 0.24. So we're using that value when we test. We're going to test n times p greater than or equal to 10. So n times p is going to be 1,019 times 0.24. All right, and for that I get approximately 245, which is definitely greater than or equal to 10. And then we need to check n times q, or 1 minus p. And when we do that, we get approximately 774, which is definitely greater than or equal to 10. Okay, so this is a difference. This is a difference from the confidence interval. For the confidence interval, we used p hat and q hat because we didn't know we didn't know p. Now we are assuming that p equals 0.24, which is what the null hypothesis says, which is what the company says. So now that we have checked our model, we can now say that our sampling distribution, so we now know that our sampling distribution for p hat is approximately normal. And remember, approximately normal, that's important to say that it's approximately normal. So we have approximately normal with a mean of 0.24 and a standard deviation. So we're going to have to calculate the standard deviation. So remember, we're going to have, and this actually we're going to call standard deviation instead of standard error, because remember now we're using p Q, and then of course N. So because we're going to use the 0.24. So I get 0.0134 if I round to 4 decimal places. So that's my standard deviation I'm going to use. From there, I'm going to go ahead and draw my normal model. So we have 0.24. I'm going to pause this and go ahead and do these calculations on the side here. All right, so here is my normal model. So I have 0.24 as my mean. Again, this is what the company claims to be true. And you can see with my going out 3 standard deviations each direction using my standard deviation I calculated for our sampling distribution, this is the model I get. Now, one thing I want to point out to you, I've done a lot of work and I haven't talked about p hat at all. So now I'm finally ready to talk about p hat. So from our sample data, we had 178 blue M&Ms out of 1,019. So that gave us a proportion, a sample proportion of approximately 0.1747. Now I'm finally ready to talk about, okay, here's what we got. How unusual is that? So if the true proportion really is 0.24, and we got, look at this sample proportion we got, well, it is more than 3 standard deviations below. So our sample proportion is more than 3 standard deviations below the mean. So just looking at this, we know that it's very unlikely to occur. I'm going to have to stop this video and do this in 2 parts because sometimes I have trouble uploading it to our webpage. So make sure you check the next part and I'll continue on.